Hey everyone, today I'll be showing you the basics of integration. This includes the power rule, some integration of trig and exponentials. Integration is basically the opposite of differentiation. If you differentiate x squared, we get 2x, and if we integrate 2x, we get x squared. So let's integrate some simple polynomials. If we integrate x cubed dx, now dx is just with respect to x, as we have an x function. So we come to using the power rule, x cubed, so x to the power 4 over 4 plus c. Now this c is known as the constant of integration. When we differentiate a function such as 4x plus 6, that just becomes 4. When we integrate 4, we get 4x. See, in between there we've lost a constant, so we stick in a constant of integration just in case there was a constant there. It could be 0, it could be a million, it could be -2, it could be 4. But we stick it in there just to be safe. Now let's move on to polynomials. If we integrate x to the power 4 plus 6x squared minus 12 dx, so again with respect to x. Now again we can use the power rule for each one of these terms. X to the power 4, we get x to the power 5 over 5. 6x squared, 6 is the constant, so we can just take that out, plus 6, and still integrate the x squared using the power rule. So the integral of x squared using the power rule becomes x cubed over 3. And then minus 12, well, we can think as that minus 12 have an x to the power 0. X to the power 0 is just 1. So then x to the power 0, we got x to the power 1 over 1. So that will be minus 12x plus c, again using our constant of integration there. To check this is right, well, I'll just simplify that first. To check this is right, we can always differentiate this, see if we get back to our original function. So say if we were to differentiate this quickly, derivative of x to the power 5 over 5, that is 5x to the power 4 over 5 plus 6x squared minus 12. And you notice as those 5's cancel out, that is exactly the same as our original function. So therefore we can show that we integrated correctly as we can differentiate back to our original function. So now we're going to move on to some integration of factors and negative powers. So let's have our negative power. Say we have x to the minus 2, and we're going to integrate that with respect to x. Whenever you integrate, it's normally best to keep your powers in the numerator. Now x to the minus 2 can be written as 1 over x squared. Now 1 over x squared seems a lot harder to integrate than x to the minus 2. So as we keep it as our x to the minus 2, we can integrate x to the minus 2 dx, again using our power rule. That becomes x to the minus 2 plus 1 over minus 2 plus 1 plus c, which is x to the minus 1 all over minus 1 plus c. And that can be simplified down to minus 1 all over x plus c. Now we can also have factors within our negative powers, but let's do a factor one first. Integrate x to the power half dx. Now again we can just use the power rule here, and that will become x to the half plus 1 all over half plus 1 plus our constant of integration. Now half plus 1 is 3 over 2, so that becomes x to the 3 over 2 all over 3 over 2 plus c. Now if we mix these two together, say we had to integrate 1 over x to the 3 over 2. Now, obviously with respect to x, if we integrate that, or we can rewrite that actually, first it's x to the minus 3 over 2 dx, which then becomes x to the minus 3 over 2 plus 1 all over minus 3 over 2 plus 1 plus c, and that will equal x to the minus 1 over 2 all over minus 1 over 2 plus c. Now here we can use the fact that if you're dividing by a fraction, you can times by the reciprocal, so that will become minus 2 all over root x plus c. If you wonder where that comes from, this is the fraction we're dividing by. The reciprocal of that is minus 2 over 1, which is just minus 2, so we can times up by minus 2. And if we take that minus a half down, we'd have x to the half, which we all know is root x. So that becomes minus 2 over root x plus c. So now if we move on to some trig, here, this is the best way that I think to remember how to differentiate and integrate your trig functions. Say if I had sine x, if I was differentiating, I go clockwise to cos x. If I was integrating, I go anti-clockwise, and this is minus cos x, sorry. So let's do some integration of trig. If we have the integral of sine x plus 3 cos x dx, well, the integral of sine x we have is minus cos x. Again, with our constant, we can just put the plus 3. Now, the integral of cos x using our graph, or using our quadrants, is 3 sine x plus c. We still need to put the constant of integration here, only because we do not have any limits on our integrand. So therefore, we just add the constant to be on the safe side. Let's do another one. Let's have 5 sine x minus 1 over 2 cos x dx. Okay, so then that becomes minus 5 cos x. So then minus 1 over 2 sine x plus c. Now lastly, we're going to do some exponentials. Integrating exponentials is very easy because they most of the time don't change at all. Well, if they do change, they change very little. Integral of e to the x dx, that is just e to the x plus c. And the integral of e to the 2x dx is e to the 2x over 2 plus c. Now this over 2, with exponentials, we just keep our function the same, e to the 2x, then we divide by the derivative of whatever our function of f of x is. So here our function of x is 2x, and the derivative of 2x is 2, so we divide by that. Then therefore the integral of e to the 2x is e to the 2x over 2 plus c. So that's the basics of integration. You won't need to know much more than that if you just learn the basics. There are obviously a lot more trig functions such as tan, cot, cosec, secant, but they're more advanced trig and they can be found in integral tables most of the time. If you have any questions, please leave a comment and like and subscribe.